Coming to the 28th question, it's given y equals x cubed cos x raised to the power of x plus sine inverse of root x. Now let us split it as two functions. Let me differentiate this separately and this separately. Now let me take this as y equals x cubed cos x raised to the power of x. Now I can rewrite this as x cubed into e to the power of x log of cos x. Now let me take u as x cubed. So this implies when I differentiate with respect to x, I'll get it as du is equal to du by dx is equal to 3x squared. Same way, let me take v to be e to the power of x log of cos x. So when I differentiate this with respect to x, I'll get it as dv by dx is equal to e to the power of x log of cos x. Now I'll have to differentiate x log of cos x. So that would give me u into, now this I'll have to apply the product rule again. So u dv is log of cos x, that will give me 1 by cos x into minus sin x plus log of cos x into 1 plus e to the power of x log of cos x into v dash, u dash is now going to be 3x squared. So I can now take log of cos x. Now I can take e power x log of cos x as a common factor. Then it now becomes minus of x tan x plus log of cos x plus 3x squared. Already I have a x cubed here. X cubed into this much plus and so on. I'll redo this again. So now this becomes, so when this is now going to be dv by dx. So I don't want to confuse you with this. Wait. So this is now going to be dv by dx is e power x log of cos x into, I can now write this as minus of x tan x plus log x. So now we'll apply u v dash plus v u dash. So that is x cubed into v dash is now going to be e to the power of x log of cos x. I can write sin x by cos x as minus x tan x plus log x log of cos x plus v u dash. Now it's going to be v u dash. V is e to the power of x log of cos x into 3x squared. Now this can be written as, I'll take e to the power of x log of cos x as the common factor, log of cos x. So now this becomes minus x power 4 tan x plus log of cos x plus 3x squared. So this is now going to be the for the first function. Now let us take the next function, y is equal to sine inverse of root x. So dy by dx is now going to be, now we know the differentiation for sine inverse of x is 1 by root of 1 minus x squared. So that is now going to be root of 1 minus x squared is root of x, the whole squared is now going to be x. I have to differentiate 1 by root x. Root x is now going to be 1 by 2 root x. So this is equal to 1 by 2 root x root of 1 minus x. Now let me combine the first and the second. Now I'll be getting dy by dx is nothing but e to the power of x log of cos x into minus x power 4 tan x plus log of cos x plus 3x squared plus 1 by 2 root x into root of 1 minus x. 29th question. Evaluate minus 1 to 5 modulus of x plus modulus of x plus 1 plus modulus of x minus 5 dx. Now we can split the intervals as minus 1 lesser than equal to x lesser than equal to 0. So in this, between this interval, the function now becomes minus x plus 1 plus minus x plus 5 minus x minus 5. Minus of minus x minus minus of x minus 5, which is now going to be minus x plus 5. So that gives you x and x gets cancelled. So it is now going to be 6 minus x. And the other interval is 0 lesser than equal to x lesser than equal to 5. Here the interval is now going to be positive values, x plus 5, x plus 1 plus minus x minus of x minus 5, that gives you minus x plus 5 again. So that gives you just nothing but 6 plus x. So I can now integrate it as between the limits minus 1 to 0, 6 minus x dx plus 0 to 5, 6 plus x dx. So on integration I get it as 6x minus x squared by 2 between the limits minus 1 to 0 plus 6x plus x squared by 2 between the limits 0 to 5. That gives me 6 plus half plus 25 by 2 plus 36, 5 is 30 plus 30, which is nothing but 98 by 2, which is equal to 49. The 30th question. Find the general solution for the differential equation x squared y dx minus x cube plus y cube dy equals 0. Now I can write this as x squared y dx is equal to x cube plus y cube dy, or therefore dx by dy is equal to x cube plus y cube divided by x squared y. Now clearly this is a homogeneous equation, so let me put x is equal to dy. So therefore dx by dy is equal to v plus y dv by dy. So substituting for dx by dy as v plus y dv by dy is equal to, in the place of x I will put it as v cube y cube plus y cube divided by v squared y squared into y. Now cancelling y cube throughout, I will get it as v cube plus 1 by v squared. Now bringing the v which is on the left hand side to the right hand side, I will get it as y dv by dy is equal to v cube plus 1 by v squared minus v. This is equal to v cube plus 1 minus v cube by v squared. So v cube gets cancelled, so I am left with 1 by v squared. So now you can separate the variables. Now this becomes, or other words, it is now going to be v squared into dv is equal to dy by y. Now integrating on both sides, I'll be left with v cubed by 3 is equal to log y plus c. Now substituting back for v cubed, you get it as x cubed by 3y cubed is equal to log y plus c. Now coming to the 31st question, solve the following LPP graphically. Minimum z is equal to, minimize z is equal to 5x plus 7y. And the lines given are subjected to the constraints 2x plus y is greater than equal to 8 and x plus 2y is greater than equal to 10, where x comma y comma greater than equal to 0. So we can now draw the lines taking 2x plus y equals 8. So that gives you this line 2x plus y equals 8, and this line represents x plus 2y is equal to 10. So we can see that the point of intersection is 2, 4. Now the points are 0, 0, 4, 0, 2, 4 and 0, 5 are the points of constraints. Now we'll have to see the minimum value of z. So z at 0, 0 is 0. Z at 4, 0 is 4 times 5 is now going to be 20 plus 0, which is equal to 20. And z at 2, 4 is 5 2s are 10 plus 7 4s are 28, which gives you 38. And z at 0, 5 is 0 plus 7 5s are 35 is 35. So we can see that the minimum value is at 20. So the minimum value is now going to be z at 4, 0. The 32nd question. A bag contains 2 coins, one biased and the other unbiased. When tossed, the biased coin has 60% chances of showing heads. One of the coins is selected at random and tossing it shows tails. What is the probability that it was an unbiased coin? Okay. Now let E1 be the event of getting taking a biased coin and E2 be the event of taking the unbiased coin. So now we can see that P of E1 is equal to P of E2 is equal to R. Let A be the event of showing tails. A be the event of showing a tail. He says P of the biased coin showing tails, heads is, let P of a biased coin showing tails is, okay, he says is showing heads is 60%. So showing heads is equal to 60%, which is equal to 60 by 100, which is equal to 3 by 5. Same way, P of a biased coin showing tails will be 40 by 100, which is equal to 2 by 5. Now he says the second coin is unbiased. The probability of showing tails is always half. So what we need, the required probability is P of A by E2. Sorry. Since the second coin is unbiased, the probability of showing the tails is always half. Therefore, P of A by E2 is equal to half. Now, the required probability is nothing but P of E2 by A. Now, by Bayes' theorem, we know P of E2 by A is nothing but P of E2 into P of A by E2 divided by P of A1 into P of A by E1 plus P of E2 into P of A by E2. Now substituting the values, you get P of E2 is half into P of A by E2 is also half divided by P of A1 is half into P of A by E1 is 2 by 5 plus P of E2 is half and P of A by E2 is also half. That gives you 1 by 4 divided by 9 by 20. This one. Or this is equal to 1 by 4 into 20 by 9, or which is equal to 5 by 9. Hence the required probability is 5 by 9.